So another example for Djkstra algorithm. Suppose we have to find the shortest node route from node A to F. So we know that the starting point or the path will be from A. So we will write that path and the nodes which are subsequent nodes. So B, C, D, E, F. So you can see the cost from A to B is given equals to 4. The cost from A to C is given equals to 4. Cost from B to C is given to 2. Cost from C to D is given 3. D to F is given 2. C to F is 6. C to E is 1. And from E to F is 3. Okay. So the first node means from where we will start will be A. So we'll write it here. So the cost from A to B is 4, and basically we are going from, can say, A. So we will write it as A comma, sorry, we will write the cost first and then the path A. In a similar way, just to have more space, in a similar way for C we will have cost 4 comma A. Now A is not connected to D, E and F, so the cost of D, because they are not discovered yet, will be infinite. Okay, we can use another sign for infinite, which is this sign also. Okay, now out of these two, B and C, we have to see which one has minimum cost. We can see clearly here that both of them have the same cost, so we can use any one of them. So let's say we use C. So A comma the next node will be C, and we will circle around C, denoting that we already used now C. So if we want to reach B through C, the cost will be 4 plus 2, so that will be 6. So that means this cost or the route will remain same. We will not change it because it already has 4 as the cost. Okay, then to C, obviously it's the same node, so it will remain same. Now C is connected to D, E and F, so we can clearly say from C, if we are taking C as the subsequent node, reaching to D will be 4 plus 3, 4 plus 3, so it will be 7, and we will write through C, so we will write C. To reach E, it will be 4 plus 1, so 4 plus 1, it will be 5 comma C, as we are going through C. Then we can clearly see that reaching to F, it will be 4 plus 6, and obviously through C. Why I choose to use C in this example is that we can see clearly by using the root C, both of them have same cost. So if we are choosing C, we can easily discover D, E and F in the next row, or in the next iteration we can basically discover all the remaining nodes of the network. So that's why I choose C. Now out of all these nodes, you have to find out which one is having the minimum cost. So the minimum cost is with B, 5, because B is not discoverable, so not used as a path, it's already discovered, sorry. So it will be A, C, so we have to discover all the nodes, and when we have see that there is a redundancy, we have to remove that node. So if we are using B for the root, so For B it will be remain same. Now if we are going through C to B, the cost will be 6, so it will be remain same. Now if we are going to D using B, so then it will be 4 plus 2 plus 3, the cost will be 9, so it will remain same. If we are going to E, through B, then the cost will be 4 plus 2 plus 1 7, so it will remain same also. Then if we are going to basically F through B, then it will be 4 plus 2, because C is discovered only, C, so it will be 12, so it will remain same also. Okay, now out of these 3 remaining nodes, we have to see which one has minimum cost. So we can clearly see that E is the winner here, so we can say it's A, C, B, E is the next, and we will circle around it. Okay, A, C, B, E. For B again, there is no change in the cost. C again, there is no change in the cost when we are using E as the intermediate node, because E comes after C. Then for D, if we are reaching through E, so we cannot reach through F, that's the only different route, so this cost also remains same. E is itself, so it will remain same also. Now when we discovered E, so the minimum cost to reach E through F through E will be 4 plus 1 plus 3, so it will be 8 comma C. Okay, now which one out of these 3 nodes have minimum cost? So that we need to find out now which one is having. So sorry, only 2 are left, D and F are left. So this cost is 7 and this cost is 8. Okay, so we will use 7 comma C. So 7 comma C means we will use now, which node we will use? We will use this node, which is D, so then it will be B, E, D. So we will use it for the purpose of the root discovery now. When we will use even D now as an intermediate node, there will not be any change in the cost of B, C, D and E. Okay, so only we can try is for 4 plus 3 plus 2 for F, which will be 9. So again this will remain same. Now only one node left is F, so it will be A, C, B, E, D, F. So we will introduce F now and we will see the cost again. Again these costs will remain same, you can calculate it. So now we need to now see that this is basically the root for EDF. So the best way is that we remove the intermediate nodes and we basically say that which one are redundant, we can remove it. So when we are going from AC, we don't need B here, so we can just say we will just use the root BE. When we are going to F also, so it's basically BEDF. Again when we are going from E to F, then D is also not coming in between, so we can then use BEF if we are going to this. Depending upon which node you are going, you can select it.